Hey y'all, welcome back to my channel. So today we are looking at combining like terms. So I hope that this helps you all, and don't forget that I do make a mistake for my students to identify for extra credit. So let's get started. Okay, first let's look at some notes. So let's start identifying parts of an expression. So my students have been working with expressions, and so now we are going to look at the different parts of them. So terms. Terms are parts of an expression that are separated by addition and subtraction signs. So looking at this example down here, that means that 2x would be a term, because here is an addition sign. Even 4 would be a term. So anything with a variable or a variable itself and constants are terms. So then 5y is a term and 24 is a term. Okay, so now we have coefficients. Now, coefficients are numbers that are multiplied by a variable. So I tell my students that those are the numbers that are in front of those variables. So 2 would be considered as a coefficient. Now, 4 would not be considered a coefficient because it does not have a variable. It's not being multiplied by a variable. So here is a coefficient. Spelled that wrong over there. So now, like terms. Like terms are terms that have the same variable or variables that have the same exponent. So sometimes you will, or even like terms can be numbers. So notice that this has 2x and this has 5y. Well, they don't have the same variable. So that means they are not like terms. Now notice this number, this term and this term does not have a variable. They are what we call constants. So constants are numbers, not variables. So since they are both constants, those would be considered as like terms. So that means you'll see in the example, we can combine those. But since these do not have the same variable, we cannot combine those. But if I came off to the side, or if this expression continued and said 3x and had a term, notice that this one has an x and this term has an x. So that means these are like terms. You could even have subtract x, and so of just a variable, not even a variable with a coefficient, all three of these terms would be like terms. And now we're going to look at examples to see what we would do with those like terms after one more notes page. So when you are combining like terms, we looked at the distributive property in the last video when we were generating equivalent expressions. So if there is a set of parentheses with a number on the outside with no sign, then that means that's the distributive property. So when you're combining like terms, distribute first if there is the distributive property. Then you're going to combine your constants and your variables. So the numbers with the same variable and numbers without variables. And we looked at that in the last example, or in the last notes page. So the x's we can combine. The constants we can combine. So you can multiply and divide numbers and variables, but you cannot add and subtract them. And what I mean by that is on the distributive property, you can multiply 3 times x, which would give you 3x. And you can multiply 3 times 4, which would give you 12. But now here, where it has 2x plus 4, you cannot add those two. So we could multiply them, but we cannot add them. So you could even have 3x divided by 3, and that just means 3x divided by 3 would give you x. So you can do that, but you cannot do 24 or 2x plus 4 or even 4 subtract 5y. You cannot do that unless you know what x and y represent. That's when you can start doing things with numbers or constants and variables. But until then, you cannot add and subtract them. You cannot combine those numbers. Okay, so now let's look at some examples. So the first one, we have 4 plus 4x plus 2 plus x. And I want to go back to these manipulatives just to kind of model it for you so that you can grasp a better understanding. So if you didn't watch the generating equivalent expressions, then this, just a little reminder, this long piece, this represents a variable. So the green side, that represents a positive, and then the red side represents a negative. But since we don't add and subtract or multiply and divide negatives in 6th grade, I tell my students, this is adding a variable, this is subtracting a variable. Okay, and then these little pieces here, these are your ones. Same situation, the yellow side is you are adding 1, and then the red side would represent a negative, but I tell my students it's subtracting 1. So let's model this expression that we have here. So we have 4 and then 4x. So that just means we have 4 x's plus 2 plus an x. And you can even put your little addition signs here. So that means I want to make this smaller. I'm generating an equivalent expression here. So notice that I have some yellows here and some little yellows here. Those are ones. So I can put these together in a pile or in a group, better wording. And then these are just alike too. So I can put them in a group. So if I write this expression now, that would be 1, 2, 3, 4, 5, 6 plus 1, 2, 3, 4, 5 x, because I have 5 x's. So here is my combined like terms, my equivalent expression for this one. So I just combined a like. So that means these two, they don't have variables, so I can just add those two numbers. These two have variables and they're the same variable, so I can combine those. Okay, so now let's look at the next example. I'm going to distribute first because look here, we have the distributive property. So that means I'm going to distribute or multiply everything in the parentheses by that 2. So remember, we can multiply constants and variables. So 2 times b is 2b, and then 2 times 5a is 10a. And so you bring the sign down. Then I tell my students, bring everything else down. So now, if I modeled this, we're going to look at these a little bit different. Since we have 2 variables here, we have an a and a b, I'm going to let the green represent a, and I'm going to let the red represent b. So I have 3 a's, and then plus 2 b's, remember the red is representing b, plus, I don't know if I have 10, but we'll try. 1, 2, 3, 4, 5, 6, 7, and we're just going to draw some. So we have 7, and then 8, 9, 10. Okay, so I remember the green's representing A's, the red's representing B's. So I'm not going to be able to put these reds and greens together. So that means I can put all of my greens with my green and combine those. So I really don't have anything to combine with these B's, and that's okay. That is okay if there's stuff that you cannot combine. You just leave it as is. So my new expression will be 2B plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 A's. So once I got here, I can combine these two because they're the same. But I don't have anything I can combine these two, so I just drop it straight down. And this will be my final answer. So now I'm going to show you how you can do it at home without manipulatives like this. So now I have 1y, so I can draw a little long and put a y, plus 11 x's. So I can even draw out 11 x's. Plus 7 y's minus 7 x's. Okay, so now, notice we have a y here and a y here. So I can put all of my y's together. I can say, hey, this y is going to come over here. Now, this one is going to be a little different, and this is why I wanted to show you this example. Because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's here. But on down here, it says to subtract 7 x's. 1, 2, 3, 4, 5, 6, 7. So I'm subtracting these. So that means on this 11x, I'm going to take away 7 of them. So when I combine them, I'm really taking them away. 1, 2, 3, 4, 5, 6, 7. So all of these are gone. So this one, when we combine them over here, we're taking them away. So that means when I'm looking at, because remember, we combined this one. We brought it over here. And we're adding those. So now, what do I have left? I have 1, 2, 3, 4 x's. I have 4 x's. And I have 1, 2, 3, 4, 5, 6, 7, 8 y's. So if I'm looking at it, I combine this here. And then here is another set of like terms. Okay, last one. So let's try to do it without modeling. I have 8m plus 14, subtract 12, plus 4n. Okay, so I'm going to start first with my first term, 8m. Do I have any other n's, or m's, I'm sorry, any other m's in my expression? No. So I'm going to bring it straight down. There's nothing else I can do there. Now I get to 14. Well, 14, and then I have subtract 12. Here's another term without a variable, but it's telling me I'm going to subtract that variable, or that constant, sorry. I'm going to combine these like terms which are constants. So 14 subtract 12 is 3, and since it's a positive, I'm going to put an addition sign. Or I even say, bring that one down for right now. Now, in 7th grade, you're going to learn a little different rule there. But for 6th grade, we're looking at this as bring that addition sign down, 14 subtract 12. Then I have 4n. Do I have any other n's in my expression? No. So I'm going to bring it down and say 4n. So my final answer is 8m plus 3 plus 4n. Thank you all for watching. I hope that this helps you on your assignments while you're at home. Don't forget to give this video a thumbs up. Don't forget to hit that red subscribe button so that you can keep up with the videos and just fun little things that I post on my channel. So we'll see you all next time. Stay safe and healthy. Bye, y'all.